Good evening and welcome to Python Coding Lab. I hope you're able
Good
to hear me
evening.
fine. Yeah. Hey.
Yes,
So
I can hear you.
perfect. So I have three problems again for you guys, and I'm going to show you the three problems now, and also going to share the link. And the link is coming in the chat right now. Yeah, it should be there now. I'll describe the problem in 30 seconds. You guys can download those files first. So we have three problems today. Okay, I'm going to go in the order of difficulty. So I think the easiest one is today is the odd replace. So this problem basically is that you are given a string and you have to replace every odd character with a hyphen sign, a dash sign. And the replacement of that dash sign, basically the odd character is how humans count, not how computers count. That's the only thing here. So the input, let's say with the, let me open another tab. So there are three inputs that are going to go. So for example, Saturn should turn to this string. And then, for example, a string 1, 2, 3, 4, 5, 6, 7, 8, 9 should turn to this. So basically every odd character, we are putting a dash there. So that's problem number one. The next problem is called first unique. Okay. In the first unique problem, you're given a string again, and you have to find the first unique character in the string. Okay. There might be many unique characters present, but you have to find the first unique character. And if the unique character is not present, then you have to return an empty string. So this is the example here. So you can run that. I'm just quickly running, making sure that there should not be any syntax error, but yeah, it's all good. So that's the second problem. Any questions? I'm going to give you the third problem now. The third problem is called superstitious. So in this problem, basically, you can read the description. So I'm going to buy a house, but I'm a little superstitious. Basically, all I want is that house digits should add up to an odd number. And the scheme of my adding is such that I'm going to reduce that number till I get a single digit number in the end. So for example, the number 101, when you sum it, it yields 2. If it's an even number, then we reject it. If the house number is, let's say, 149, then I add it, it becomes 14. It's above, it's not a single digit number. So I'm going to add it again, 1 and 4, and yield a 5. If this is an odd number, so I return accept. In my code, I think we are supposed to return true and false. Yeah, true and false. So you can see there are some test cases there, which are basically giving an input and true and false there. So that's the problem number 3. Any questions?
Manshu, can you go again with the problem number 2?
Yep, sure. Yeah. Any question?
So do we return the index of the non-repeating character?
We return the character itself.
The variant itself. Oh, okay, I get
Yeah.
it.
Cool. Okay, time is 7:08. I'm going to give you till 7:45. We should be more than enough time to get all these problems done. And all right. All right, time for solutions. So let's go with the problems. The first problem was odd replace. Whoever was able to do it, you can put it in the chat, so I know that how many of you were able to complete that. So this is a relatively a pretty easy problem actually. All you have to do is basically replace the odd characters with a hyphen. So let's just quickly look into the solution for this. Suppose you have an input string as something like, let's say, Saturn. Then for humans, for computer, this is the index. For humans, the index is basically this. So in that way, I was just saying replace the odd character. So you need to get rid of this, this, and this, which essentially comes down to an even index for a computer. If something is an even index, you basically replace it with a hyphen. And what you can do is you can basically begin with an empty string and then iterate over the whole string. And every time you encounter an odd character, a character placed at the even index, sorry, you just replace it with the hyphen. So let's look at this solution. So I'm going to say, let's say my answer equals to an empty string. And what I'm going to do is I'm going to iterate the string from left to right. So just going to say for x in S, and it's going to say if that particular character for x in, sorry, x in range of len of S, because we need to deal with the indexes. Range of len of S. Then basically, once again, I'm going to say if s of if x is even, and that I can say in some ways, but I'm just going to choose a simple way. If x is even, then basically answer plus equals a hyphen. Else answer plus equals the s of that index. Basically give me the letter on that index. So if the index is even, then basically add a hyphen. Otherwise, just add the word as it is. And then basically return, in the end, return S. So that's the solution I can think of. Let's just try to run this. So Python 3 and then odd replace. Seems like there is a problem in what is, oh, sorry, my mistake. No, what is that? I is not defined, my mistake. So what I did was I used a wrong, this should be X, not I. So I'm going to say just quickly.
You have to return your answer, right?
That is also correct. Thank you for correcting. So I'm going to say just S of X and then return answer. So a couple of problems in the solution. Now let's go back, try to run this code. And now it's working fine. So that's pretty much it. Pretty simple problem. Basically, all you have to do is just check the indexes, the number of the index, and then basically append the correct sign. So that's problem number 1. Now let's go to the problem number 2, which is first unique. So let's just, first of all, let me just make sure that this is running fine. Yes, it is running fine. So let's go to the solution. So first unique, let's look at what do we need to do here. Suppose I have a input as something like, let's say, my name. So let's just put it as trigonometry. Suppose this is the input. Then essentially what we need to do is we need to find the first unique character, right? The brute force algorithm is really simple. That is, you're going to run a loop from left to right and pivot on each index. Suppose this is the index 0. So pivot on this and check the rest of the string if this character repeats. If this character does not repeat, then this is the answer because you're going from left to right. But if the character repeats, then you go to the next one. So T repeats here. So this is the index and this is the character. This repeats, so this cannot be answer. Then you go to the next index, 1, R. Does R repeat? R repeats. So that is not an answer. Then you go to I. Does I repeat? No, I does not repeat. So that's the answer. That's, you found the first unique character. So you can do that way. Like 2 for loops you can write, or you can basically, if you're Python, basically you can just do a count. So you can go to each character and count the number of occurrences of that character. If the count returns more than 1, then it's not a unique. If count equals 1, then basically you found the first unique. So if I do any of these approaches, basically writing 2 nested for or using count inside of for, the number of operations that I'll be performing would be n square. This can be reduced, and this is where the dictionaries come in very handy. The hash maps come really handy. The introduction of a hash map can take the complexity down by 1 order. And what I'm going to do is I'm going to write a for loop to iterate over this whole string and construct a dictionary which with the count of each character. Then I'm going to iterate over the string again and check the first character which has the count equals to 1. So I don't need to really look for the character again in the string itself. And the looking up in a dictionary is constant time. So let me just show that solution first. Suppose the string is, once again, trigonometry. And I hope that's the correct spelling. No, there is no O here.
All right. Both uppercase, lowercase, we treat them the same, right?
Yeah, you can treat the lowercase, uppercase, however you want. So you can treat either way. I'm keeping it the same. So
yeah, K is agnostic, right?
Right. So that's correct. So I'm going to keep the lower and uppercase the same. I'm going to treat them the same. So first, I'm going to do 2 for loops. In the first for loop, I'm going to go from left to right and construct a dictionary. So for each character, I'm going to construct, let's say there is a dictionary with T as, let's say, 2, and then R as 2, I as 1, and then G as 1. So I'm going to do that, construct the whole dictionary like that. Then I'm going to write another for loop. I'm going to say for each character in this string, and I'm going to check if that character count, if the char count is equals to 1, then basically return character. That's going to be the simple logic. Now this check here is O1, which actually saves the time for us. This is the thing that is saving the time for us. In 2 for loops, each time you search for something, 2 for loops or having a count inside a for loop, each time you search, it's going to do a full search of the string. So if the string is n length long, they're going to be n comparisons. So inside the for loop, you have on. So the overall complexity becomes O of n square. With this approach, you write for loops twice. And the first time you construct the dictionary, and the next time you look up in the dictionary, and look up in the dictionary is O1. So both the loops are O of n. Let me write the solution, and that will become even more clear. So in the first iteration, I'm going to construct the dictionary. My dictionary, let's say, is called counts. Now I'm going to go through the string and say for x in s, basically add the character to the dictionary if it's not present with a count of 1. If it's already present, then basically increment the count. So I'm going to say simply count of x equals to count dot get x and put a 0 there. Actually, today let me code it in a slightly simpler way. So I code it usually this way. I'm going to code it in this way. So I'm going to say if x in count, then basically count of x plus equals to 1. Else count of x equals to 1. Right, so I'm constructing this dictionary. I'm using the syntax here. This takes 4 lines to do that. You can do it in 1 line. So basically, I'm checking if this x is already present in the count. If it's present, then basically increment it by 1. Otherwise, initialize it with 1 value. Now the dictionary is constructed. At this point, let's just print the dictionary and make sure that we are able to at least get the dictionary right. So I'm going to go back. The solution is not going to work, but I'm just going to see that I'm getting the dictionary right. So as you can see, the dictionary is getting printed. So we are good so far. Now I'm going to write the loop again. And in this loop, I'm going to iterate from left to right again. I'm going to say for x in s. Now I'm going to do the check. If count of x equals 1, then return x. That'd be the answer. However, let's say there is no such character. There is no such character in which the count is equals to 1. That is, every single character is repeating. For example, this string here. Then in that case, you basically return an empty string. So if the program control reach to the line 25, that means we have not found that character and we are returning an empty string. So let's save this.
Hi, Himanshu, have a question. Like a dictionary need not be an ordered, right?
It need not be ordered. So Python dictionaries till 3.6 were not ordered. Okay, but from 3.7 they have become ordered. Whether the dictionary is ordered or it's not ordered, it does not matter, right?
In that case, say if there are 2 unique things, like the 2 unique things, then we might not be fetching the first one, right?
No, so we are iterating in this string, right? From left to right, string is ordered.
Oh,
the
okay.
very first character that gets a count of 1 will be the answer, right?
Oh, okay. We are iterating the string. Okay.
Yeah. So let's run this code now, and we have the answer. So empty case is returning an empty here, and the rest of the characters are returning. Whoever were able to do this, so each of you can basically just, for yourself, just put the number of problems that you were able to do. So I get an idea of like what were you able to accomplish. And I'm going to move on to the third problem. So the third problem is superstitious. So in this problem, basically what we have to do is we have a number. All we have to do is repeatedly sum the digits of the number till we get to a single digit number that is less than 10. and then find out whether it's an odd even number. So let's assume that number is 169. If we sum the digits, then this will be 15 and 116. So this is still not a single digit number. So I'm going to sum this again, and this becomes 7. At this point, this number is an odd number. Hence, this is an okay case. Whereas let's say something like 101, this sums to 2. This is an even number, and hence this is not a good function for me. Sorry, a good number for me. So I just need to basically do this logic. That's all. So let's do this. Okay. First, what I'm going to do is, let's just quickly understand how do we calculate the sum of numbers, right? Sum of the digits of numbers. Suppose you have a number called 145. Okay. If I want to find the sum of all the digits here, what can I do is basically I can write a loop on this number. The loop can be something like, let's say, while the number is greater than 0. And in each item, I'm going to divide this by 10. When you divide it by 10, what happens is it generates basically a quotient and a remainder. When you divide by 10, it will divide 14 and 5 will come out. So with this remainder, you can actually construct the sum of these digits. Suppose you have a running total, which you initialize to 0. The first number comes out as 5, so total becomes 5. Then this 14, you again divide it by 10. So this generates 1 and 4. So you add 4 to this. And then similarly, this 1, you again divide by 10. So the quotient comes out as 0, and the remainder comes out as 1. You add 1 to it, and that gets to 10. So in this way, you can continue this logic to divide and add the numbers. Right? So that should be okay. That should be okay to do. The only thing here is that you will have to repeatedly add numbers. So let's do this. One small thing. So here, when the number becomes 0, this loop will break. So let's write this. What I'm going to do is, to make it clean, I'm going to keep 2 functions here. So let's begin with the first one. Suppose I'm going to write this, that while the number is greater than 0. Okay. I'm going to say number equals to calculate sum of number. So consider this to be a magic function. Okay, this is a function which computes the whole sum of all the digits in a number, and it returns back, and I'm reassigning it back to the number itself. Okay, and then this loop will keep repeating till the number is actually greater than 0, or I can put this number is, sorry, my mistake. Number is less than 10. Till the number is less than 10. So basically, till we get the number to a single digit, keep doing this. Right? At that point, you can basically. Sorry, question?
Don't you think it should be greater than 10 while it's greater than 10, and then we do?
I can't hear you, Nile, properly.
So I'm saying on the while statement, should it be if while number is greater than 10, and then we do the sum of the digits instead of less than 10, right?
Yes, that is correct. So while number is greater than equals to 10, till then you have to do it. Sorry, yeah, thank you for the correction. Till then we have to do this. And then once this is done, we have to just return even or odd case. So I can just do a comparison here. I can just write something like number modulo 2 equals 1. So this will either return a true or false, and then the true or false can be returned back as an answer. Now I've created a helper function here called calculate sum. So let's do calculate that helper function. Suppose that so I'm going to create a helper function. It's called def calculate sum of, let's say, num. Let's say that it's returning 1. Okay, let's just say that it's returning 1, and make sure that I'm just checking whether the code is okay so far. Okay. So I'm going to run the Python 3 Superstitious. So it's going to return true, 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 true for all of those, because this function is returning 1 at the moment. But now I need to get to finding out the sum of all these digits. So okay, let's begin that. So I'm going to say while the num is greater than 0, this num I'm referring to, and I'm going to keep a number called total equals to 0, where I'm going to sum these things. Now I'm going to say there are two things. First, I need to calculate the remainder. I can get with the division of 10 here. So I need to calculate the remainder. Remainder I need to add to total. So I'm going to say total
Hemant, function call is before the function definition. So that is okay, right? Like it worked, the code worked. So it's not an issue, right?
What is the question again?
Function call, you're calling it, and then you have defined it, but the code worked, so it is working, right? Like, I mean, in Python, basically there is no issue, right? That way.
So it depends how you're coding. So if you're doing everything in script mode, then it will be a problem, because if you call it here, then the code has not seen that function so far. So that will be a problem. But I am using this if underscore name underscore main. So I'm executing from here. So all the definitions are available to me before I get here. So it will work.
Okay.
We can talk about it after this. So I'm going to do this total, this, and then I'm change the number, because each time you divide the number, for example, the number 145 divided by 10 generates 5 as remainder. So I add 5 to the total. Then the number becomes 14. So I need to change the number to that. So I'm going to say number equals to number by 10. I can write the shorthand for these as well, or basically I can write it this way as well. So, and then in the end, return total. Usually when we write such helper functions, it's a good idea that we can always test those functions by passing some input and make sure that it's working fine. But let's just quickly do a sanity check, and let's just run this code. So what is happening here is true. So first three cases are correct. Last case is failing. I'm wondering if the last case is correctly failing or not, because last case maybe.
No, it should be true.
No, I think it is incorrect. I mean, all the 9s, they will be 9. Okay, you will be left with 9. 9 is an odd number.
Right.
So it should be true.
So when you're adding it, it becomes 9 in the end?
Finally, you'll be left with resolving into 9, which is odd, which shall be true.
So this should be true. This should be true.
The test case is incorrect.
Yeah, the test case is incorrect. Yeah, that's what I was coming down to. I think the test case probably is incorrect.
Yeah.
Right now.
So every 9s will resolve to a 9 in the end.
Okay. Is that a basic, some kind of a mathematical trick that you already know, or you computed the sum?
No, I computed, but I know it. So basically, 9 is nothing but 0, 9, 0 plus 9. And then 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6, you'll have a 6 plus 3, 4 plus 5, you'll have a 5 plus 4, 2 plus 7, you'll have a 7 plus 2, 1 plus 8, you'll have an 8 plus 1, 0 plus 9, you'll have a 9 plus 0.
I see.
They are mirror similars. Yeah.
Okay.
Large ints, is there a limitation in Python? Like, is that some int overflow or something? Like, is there some limit?
So there is no limit in Python. So that's the advantage that we have here. There is no limit. If this was any other language, there would be a limit. So that's the solution to the third one. The idea is basically each function should do one thing, right? So I've split the two pieces of code separately. So each of them can be used separately as well, but the code is also looking slightly better. Any questions?
Himanshu, can you explain the dict function definition and call?
Which function?
That line 20, you basically called the function which is defined in 24, right? How it is working? You said it will work because you have your main, like you said, you'll explain that, right?
Yeah. So let's create a new file, okay? Suppose I'm just creating a test.py here. Okay. Suppose that I have a function called def f1, which is takes a number, and let's say it calls f2. And then I have a def f2, which basically just, let's say, print something like hello, something like that. Okay, now let's run this code. Sorry, my mistake. I was not calling this code. Let's just call this code somewhere. So let's call f1. So when you run this code, you're going to get an error. My mistake. Keep doing mistakes. Let's add this.
Oh.
Let's run this again. Now you get an error. Come on. I just keep doing mistakes. Sorry, my mistake. The error that I want to show you is, so I've run this code and it's basically, it's printing F2. That's the problem here. Problem is, let me get this guy from here and run it maybe here. If I do this, okay, let's run this. This is the error that you are talking about, that you run into. If you call something which does not exist. So here, what am I doing is basically I have F2 called here, and then I'm calling function one. Function one, when gets called, it looks for F2, but F2 is not yet defined because it's defined on line number 9. But if I move the definition of this, here,
You call it remember, so it should work.
Yep.
This one, someone will work.
Exactly.
And what is declaration in Python? Like I got definition, I got function call. What is declaration?
So declaration, what do you mean by declaration in Python?
Declaration, like there is function
defining
definition.
like x equals to 5. Is that what you mean?
Like in terms of function, I mean, I don't know that. So I wanted a good example, but that's a variable declaration. I mean, but for function, is there something?
So I mean, this is the declaration of function, right?
Okay, you're saying definition is same as declaration for.
Yes.
Okay.
So in C and And I think in C++ you are able to provide the signature without providing the definition of the function. Is that what you're referring to? Can you do something like that in Java, in Python?
Correct. That's what. Yes, that's what I've. You're correct. You can put that signature on top and use it, something like that.
Right. I
That's
don't
what
think so. Yeah, I don't think so you can do that. I don't think so. I've never tried it, but I don't think so you can do it. You cannot separate the signature and definition in different places.
Okay. And then how is that different from a call? Like it's
What do you, so I'm calling here.
yes.
Yeah, so what do you mean, how is it different? So Python is not a compiled language. Let's begin with that. So Python is not a compiled language. When you write a code in C++ like that, the code gets compiled and the signature and the definitions get bind. They are bound together during the compile time, and you can run it with, and like you can run it with this type of call and your things will resolve. Python is not like that. As you saw in this example, if I put, as you go line by line, whatever names are encountered are put in the memory at that point of time. So if something is not available, then it's going to throw an error right there.
Okay.
Any other question? All right. I'm going to pause the recording.